Hey everyone, welcome to a Euphoria Academy past paper video. My name is Ole and I'll be taking you through it. And please like, subscribe, and share if you find our videos useful. Without further delay, let's get into it. So today we're going to be doing the NSC Grade 12 Mathematics Paper 1 November 2023. Of course, we're going to be starting with question 1. Now, just a few minor details before we begin. Question 1 is about equations, inequalities, factorization, and things like solving for x. So that's what you should expect, and it should take you around, well, I guess the marks allocated, 24 minutes, and let's get into it. All right, for question 1.1.1, we have x squared plus x minus 12 being equal to 0. Now, this is already in standard form, and what we need to do is just factorize, right? So, when you factorize a trinomial like this, we need to know factors of the constant, right? So, I know I need to find the factors of minus 12 that will give a result of positive 1 when they are added together, and this turns out to be x plus 4 as well as x minus 3 being equal to 0. That's the above being factorized. Okay, so that means we're going to have a result of x is equal to minus 4 or x is equal to 3. Question 1.1.2. We have 3x squared minus 2x being equal to 6, and we are told that the answer must be answered correctly to 2 decimal places. Now that tells me that I have to use the quadratic equation, right? So in order for us to use the quadratic equation, we need to put this in standard form so we can know what the values of our variables are, right? So let's go ahead and do that. 3x squared minus 2x, we're going to bring 6 to the left hand side, so we're going to add 6, and this is going to be equal to 0. All right, now variables of our quadratic equation, we know that a will be equal to 3, we know that b is going to be equal to minus 2, c is going to be equal to 6. All right, now we're just going to write the quadratic equation, which will be x is equal to minus b plus or minus the square root of b squared minus 4ac, and everything is divided by 2a. All right, let's go ahead and substitute. We have minus 2 in brackets. I like substituting everything in brackets so that I don't forget anything. All right, and then we have 4, we have 3 here. I'm going to have c being 6 in the bracket as well, all divided by 2a, which is 2 multiplied by 3. All right, now when you put this in your calculator and you do for the positive and the negative, you're going to find that x is going to be equal to 1.79, or x is going to be equal to minus 1.21. Question 1.1.3. We have the square root of 2x plus 1 being equal to x minus 1. Now, every single time you see a square root, I know that we have to analyze the answer that we get. So whatever that we get to, we're going to have to always check if it does make sense. Whatever x answer that we get, we're going to substitute it to see that we don't get a negative in the square root. All right. Okay, cool. So the first thing that I want to do here is I want to get rid of the square root. So I'm going to square the left hand side as well as square the right hand side, and that is going to give us 2x plus 1 being equal to x minus 1 all squared. All right. Now I'm going to expand the right hand side. We're going to have 2x plus 1 being equal to x squared minus 2x plus 1. Alright, so I want to write things all on one side, and how I'm going to do that, I'm just going to take the 2x as well as the 1 to the right hand side. So we're going to end up with 0 being equal to x squared minus 4x, and that's going to be minus 1 this side, right hand side minus 1. So we're going to have 0 for the constants. Alright, now I'm going to factorize what we have there. We're going to see that we have a common factor of x. We're going to have x minus 4. I'm going to see that either x is equal to 0 or x minus 4 is equal to 0, which means x is equal to 4 in this case. Now let's check if truly x is equal to 0. So if you substitute 0 into the top part, we're going to find that 2 times 0 is 0, and then we're going to be left with 1, and the square root of 1 is 1, so the square root makes sense. We're going to substitute the 0 on this side, so it's going to be 0 minus 1, and that's going to be minus 1. So how can we have 1 is equal to minus 1? So that means that x cannot be equal to 0, right? If we substitute the 4, we're going to have 2 times 4 here, which is 8. 8 plus 1, 9. Square root of 9 is 3. 3 on the right hand side. 4 minus 1 is 3 on the right hand side. We have 3 is equal to 3. That makes sense. So that is correct. Question 1.1.4. We have x squared minus 3 being greater than 2x. So we have an inequality, and with inequalities, I know that I have to find my CVs. And how you get your critical values is you have to write things in its standard form and then factorize from there, and things will become clearer from that. So let's do that. So we're going to have x squared minus 3, and we're going to bring the 2x to the left hand side. We're going to have minus 2x being greater than 0. All right, so we're quickly going to factorize this. Let me just write it in a form that makes things simpler, being greater than 0. All right, so factorizing this, we're going to need to find factors of minus 3. So factors of minus 3 that when you add them together, they give you minus 2. All right, and we shall see that if you add minus 3 to 1, you get minus 2. So that means that factorizing this, we're going to find that we have x minus 3 as well as x plus 1 being greater than 0. All right, so our CVs, critical values in this case, are x is equal to 3 and x is equal to minus 1. All right, now looking at this inequality, we're working with a greater than sign. Okay, so that means when we do draw the parabolic function, because that's what this inequality is. It's a parabola, positive parabola, where we have our critical values of -1 there on the negative side, and the other critical value of 3 on the positive side, working with a greater than sign. So that means they're more than our critical values, so they're going to be either to the left or to the right of this parabolic function. So that means ultimately our answer to this is going to be either x is greater than 3 or x is smaller than -1, because that's going to give us the values to the left. Right, so here we have a simultaneous equation, right? So what helps is writing out the equations that we're given. We have x plus 2 being equal to 2y. That will be our equation 1. And we have 1 over x plus 1 over y being equal to 1. That will be our equation 2. So we need to make either x or y the subject of our formulas. Now the easiest one to do would be x from equation 1. So let's do that. So from equation 1, we have that x is equal to 2y minus 2, and that will be equation 3. Now we're going to substitute equation 3 into equation 2. I'm going to find that we're going to have 1 over 2y minus 2 plus 1 over y being equal to 1. Now we have a fraction here, and whenever you want to do operations with fractions, either addition or subtraction, we need a common denominator. So we're going to do that for this one. We just need to multiply by y over y, and this one we just need to multiply by 2y minus 2 over 2y minus 2. And after doing that, we're going to find that we have y over 2y squared minus 2y, and that will be added to 2y minus 2 over 2y squared minus 2y, and that is all equal to 1. Alright, now let's just add our numerator, and let's add the fraction rather, and we're going to see that we have 3y minus 2 over 2y squared minus 2y being equal to 1. Right, now let's get rid of this denominator, and how we do that, we're just going to multiply by 2y squared minus 2y over 1. Right, and that will give us 3y minus 2 being equal to 2y squared minus 2y. And let's try and get everything into standard form, and doing that we'll see that we have 0 because we just are changing the left hand side. Now taking 3y to the right hand side, we need to subtract. Taking minus 2 to the right hand side, we have to add minus 2. So we're going to see that we have 2y squared minus 5y plus 2. Now factorizing this guy, we will see that we actually need to find factors of 4y squared, which is positive, and these factors need to, when added together, need to give us 5. Well, in this case, that would need them to be negative, right? Because we have a negative 5y there. So these numbers are actually going to be minus 4y and minus y. So let's do that. I'm just gonna replace this minus 5y by the minus 4y and the minus y, and that will give us 2y squared minus 4y minus y plus 2, and from there it's easy to factorize. We're going to take out a common 2y here, and we're going to see that we have a y minus 2. We're going to take out a minus 1, and we're going to see that we have a y minus 2, and to factorize we have a common factor of y minus 2, and that is y minus 2, right? And we're going to be left with 2y minus 1. All right, that would mean that y is equal to 2, or y is equal to 1 over 2, so half. So from our previous slide, we have that y is equal to 2, or y is equal to half. And our equation 3, where we made x the subject of the formula, is going to help us out here to easily find x. We're just going to substitute our y values. So we're going to start with 2, and we will see 2 times 2, 4, x is equal to 2, or x is equal to 2, substitute the half, minus 2. We're going to see that x is equal to minus 1. All right, question 1.3, the last question of question 1, we have that 2 to the power of m plus 1 plus 2 to the power of m is equal to 3 to the power of n plus 2 minus 3 to the power of n. Now I can see that we have x exponents and it's an exponential equation, so that means I have to remember all my laws of exponents because we're going to use one or two of them, and we're told that we need to find m plus n as well as m and n are integers, which reinforces the fact that we're going to use laws of exponents, because if they were not integers, this would be something else. All right, so how we're going to do this, we're going to just separate what we need to separate. So we're going to start with the the 2 on this side. All right, so we have that 2 to the power of m plus 1. Laws of exponents say that if we're adding exponents, they need to have the same base and be multiplied to each other. So let's do that. 2 to the power of m is multiplied to 2 to the power of 1, and then here we just have 2 to the power of m, and this side we have 3 to the power of n being multiplied to 3 to the power of 2 minus 3 to the power of n. Now I can see that we have a common factor on the left hand side. We also have a common factor on the right hand side, so let's take it out. That will be 2 to the power of m, and that will give us that it's multiplied to 2 plus 1, and then on the right hand side, common factor of 3 to the power of n, and that is multiplied to 3 to the power of 2 minus 1. All right, so what we have here is 2 plus 1 is 3. What we have here, 3 to the power of 2 is 9. 9 minus 1 is 8. So let's write that. And we can see that we have a 3 this side. So that means we probably need to have a 2 that side, because we have a 2 and a 3. Probably need a 2 and a 3 this side. So we know that 8 can actually be written as 2 to the power of 3. So we have what we need. Now with laws of exponents, we know that if we equate the same base to itself, then the exponents should be equal to each other. And that doesn't change if we're multiplying with another number or exponent, right? So you can actually see that because we have a base of 2 this side, a base of 2 that side, base of 3 this side, and a base of 3 that side, that means that this exponent, the m, let me just switch to another color, this exponent, the m, this exponent's the 3, that means they must be equal to each other, and likewise for the n. So that means m is equal to 3 and n is equal to 1. Now we were told to find what is m plus n, and that will give us 3 plus 1, that is 4.